Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Waiting to buy a home? The Churchill Mortgage team says now is a great time to buy. Waiting could be a costly mistake because when rates drop, new home buyers will flood the market, driving up home prices. Go to churchillmortgage.com for your free analysis and see how home values can outpace rates to help you build wealth over time faster. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
This is SpaceTime, Series 26, Episode 66, for broadcast on the 2nd of June 2023. Coming up on SpaceTime, an ancient galaxy suddenly dies. Inmarsat says Australian satellite outages were not caused by cyber attacks. And northern Queensland residents rocked by a meteor. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers say they're stunned after the James Webb Space Telescope discovered an ancient galaxy called GS9209, which suddenly and mysteriously died, halting all star formation. The observations, reported in the journal Nature, suggest that the galaxy formed most of its stars during a hyperactive starburst period between 600 million and 800 million years after the Big Bang, 13.82 billion years ago. But then, just over 12.5 billion years ago, it suddenly stopped making new stars. In fact, when the team observed it at 1.25 billion years after the Big Bang, no star formation had taken place in the galaxy for around 500 million years. The findings are surprising because here in our local universe, most massive galaxies take billions of years to shut down star formation. Despite being around 10 times smaller than the Milky Way galaxy, GS9209 has a similar number of stars. These have a combined mass of around 40 billion times that of our Sun, and were all formed rapidly before star formation in the galaxy suddenly stopped. Analysis also shows that, like most if not all galaxies, GS9209 contains a supermassive black hole at its centre. But interestingly, it's around 5 times larger than what astronomers might anticipate for a galaxy of that size. And that could be the key. Astronomers think that this supermassive black hole could be responsible for the sudden shutdown of star formation. If correct, the discovery provides new insight in the processes involved in the early universe's star formation and the role which supermassive black holes have in halting that formation. You see, the growth of supermassive black holes release huge amounts of high-energy radiation, and that can heat up gas, preventing it from collapsing, and also push gas out of galaxies altogether. Either way, you end up not having the feed material needed for stellar formation. And so this could have caused star formation in GS9209 to stop. Webb's already shown that galaxies were growing larger and earlier than science had ever suspected. But this new work is giving scientists a really detailed first look at the properties of these early galaxies, charting in detail the history of galaxies like GS9209, which managed to form as many stars as our own Milky Way just 800 million years after the Big Bang. This is SpaceTime. Still to come, Inmarsat says a satellite outage which affected much of Australia wasn't caused by cyber attacks. And the residents of North Queensland treated to a spectacular meteor shower. All that and more still to come on SpaceTime.
We can stop HIV, Iowa.
One key step, getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
Inmarsat has denied suggestions that two recent outages of its I4F1 satellite could have been due to denial of service cyber attacks by an unfriendly foreign power. The British commercial satellite operator says two recent failures of its satellite, which provides L-band services for Eastern Asia and the Pacific region, were due to a partial loss of power. I4F1 provides the Southpan satellite-based augmentation system, which increases the accuracy of global satellite navigation systems from a metre down to just centimetres. The system supports services ranging from maritime safety operations and aircraft navigation to farmers, giving them improved precision for crop sowing, fertilising and spraying, thereby reducing their costs and improving efficiency. Inmar says the sudden loss of power invoked automatic procedures on the satellite that led to the suspension of services. While engineers are still investigating the cause of the power loss, the London-based company has ruled out space debris or anything malicious such as a cyber attack. The I4F1 satellite was built by EADS Astrium, which is now part of Airbus Defence and Space, using a Eurostar 300 GM bus. The 5,990-kilogram spacecraft was launched back in 2005 aboard an Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Base in Florida, with an initial 13-year design life. It's now been operating for 18 years. Inmarsat says the Airbus-built I6F1 satellite, launched in December 2021, is slated to replace many of the I4F1's L-band services in coming weeks. This is SpaceTime. Still to come, North Queensland residents are treated to a spectacular night show as a meteor lights up their skies. And Procyon, the brightest star in Canis Major, the bloated aging red giant Arcturus, the super red giant Antares, and the June solstice are among the highlights of the night skies on June Skywatch. Queenslanders are on the hunt, searching for meteorite fragments from a meteor which lit up the night skies of northern Queensland last week. The meteorite space rock flashed across the sky with a glowing green light seen from as far south as Mackay, north to Cairns, and as far west as the Gulf of Carpentaria. Sightings were reported across the state, with hundreds of people taking to social media to share videos. Astronomer Brad Tucker from the Australian National University says the meteor was estimated to have been between half a metre and a metre in size, and it would have been travelling at 100,000 to 150,000 kilometres an hour. Citizen scientists are now searching the outback for its landing site, with the tiny Gulf town of Croydon ground zero. That's because a sonic boom was felt by local residents at that location, suggesting the meteor could have landed near the town. The sonic boom itself would have actually been generated by shock waves as the meteor hit thicker layers of atmosphere and began fragmenting. While most of it would have burnt up, some larger fragments may have made it all the way down to the ground. Tucker says he's fairly certain the fireball was caused by a meteor rather than space junk because meteors have a characteristic look. They're a bright, solid light, and they often have a blue or green colour. Tucker says a significant fraction of this meteor would have had bits of iron and nickel in it, and it's that which would have caused it to glow blue-green. This is SpaceTime.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our two convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to its signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
And time now to check out the night skies of June on Skywatch. June is the 4th month of the old Roman calendar and is named after Juno, who was the wife of Jupiter and also the equivalent to the Greek goddess Hera. Another belief is that the month's name actually comes from the Latin word junores, which means younger ones. June is a great time to look up at the night skies and marvel at the majesty of the Milky Way, which puts on a spectacular overhead display this time of year. June also marks the winter solstice in the southern hemisphere and summer solstice north of the equator, which this year happens at 12:57 in the morning of Thursday, June the 22nd, Australian Eastern Standard Time. That's 10:57 in the morning of Wednesday, June the 21st, US Eastern Daylight Time, and 2:57 in the afternoon, Greenwich Mean Time. Here in the southern hemisphere, it's the time of the winter solstice, and of course it means the arrival of summer for our lucky listeners north of the equator. The June solstice occurs when the sun reaches its most northerly point in the sky as seen from Earth, zenith appearing to be directly over the Tropic of Cancer. Contrary to popular belief that the seasons on Earth occur when the Earth's orbit around the sun is at its nearest or furthest points, they're actually governed by the tilt of Earth's axis as it journeys around the sun in a year. So on the day of the June solstice, the Earth's south pole is tilted by 23.5 degrees away from the sun. The sun rises north of east and sets north of west. 6 months later, when the south pole is tilted towards the sun, it's the southern hemisphere summer. And in between we have the autumn and spring equinoxes. Almost overhead this time of year, we have the constellation Virgo. The constellation is named after Virgo, the goddess of justice and the harvest in ancient Greek mythology, who used her scales to weigh good and evil. However, she became so disenchanted with the evil deeds of men, she threw away her scales and retreated to the heavens. Interestingly, the ancient Egyptians also associated Virgo with agriculture. There she was the goddess Isis, who sprinkled the heads of wheat across the sky, forming the Milky Way. To science, Virgo is a tightly packed region of space containing some 2,000 galaxies, all gravitationally bound into a gigantic galaxy cluster, located some 60 million light-years away, of which our local group of galaxies is simply an outlying member. A light-year is 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The mass of the Virgo supercluster is so enormous that its gravity generates the so-called Virgo-centric flow, causing our Milky Way galaxy, as well as Andromeda and all the other members of our local group, to move towards the supercluster at around 400 kilometres per second. That's despite the accelerated expansion of the universe over cosmic timescales. The Virgo supercluster is now thought to be nothing more than a lobe of an even bigger galaxy supercluster known as Laniakea, the centre of which is known as the Great Attractor. Laniakea and the Great Attractor are among the largest known structures in the universe. Despite the Virgo cluster size, it's so far away it's difficult to see without a decent-sized backyard telescope. You'll want something at least 100 millimeters in diameter or larger. Located right next to Virgo and directly overhead this time of year is the constellation Corvus the Crow. Greek mythology tells us Corvus could talk to humans, but he was a lazy bird, and so Apollo took away his ability to speak and banished him to the heavens. One of the highlights in the constellations Virgo and Corvus is the spectacular Sombrero galaxy M104. Visible with a good pair of binoculars or a small telescope, this stunning spiral galaxy is seen almost edge-on, providing a spectacular backlit view of its galactic bold stars and the molecular gas and dust lanes in its arms. M104 is located some 31 million light-years away and is moving away from the Milky Way at about 1,000 kilometers per second. The Sombrero galaxy has a diameter of about 50,000 light-years. That's about 30% the size of our own galaxy, the Milky Way. It's surrounded by up to 2,000 globular clusters and an active central supermassive black hole at least 1 billion times the mass of our Sun. Now, by comparison, Sagittarius A star, that's the supermassive black hole at the center of the Milky Way, has just 4.3 million times the mass of the Sun. Globular clusters are tight balls containing millions of stars, which were all either originally formed at the same time from the same collapsing molecular gas and dust cloud, or they're the surviving cores of small galaxies that have been cannibalized by larger ones. By the way, the brightest star in Virgo is Spica, a spectroscopic binary located some 250 light-years away. Spectroscopic binaries are double star systems orbiting so close to each other or at such an angle that they can't be visually separated, at least not from our viewpoint on Earth. Under these conditions, their spectrum will actually be a combination of the spectra of both of the stars in the system. But as these stars orbit each other, one of the stars will be moving sort of towards us, the other will be moving sort of away from us. So, the star moving towards us will have a spectra that will be slightly blue shifted into high frequencies, shorter wavelengths, while the star moving away from us will have its spectra slightly red shifted to lower frequencies, longer wavelengths. And so the two stars in the system can be separated by their Doppler shift. Looking about 20 degrees above the western horizon in the early evening is the fourth brightest celestial object in the sky, the dog star Sirius. Only the Sun, the Moon and the planet Venus look brighter. To the northwest or right of Sirius is another fairly bright star called Procyon, the brightest star in the constellation Canis Minor, the Lesser Dog. In Greek mythology, Canis Minor and Canis Major were Orion's hunting dogs. Procyon is a binary star system comprising a spectrotype F main sequence white star, Procyon A, and a faint white dwarf companion, Procyon B. Main sequence stars are those undergoing hydrogen fusion into helium in their cores. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. They're followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, spectrotype G yellow stars, that's where our Sun fits in, spectrotype K orange stars, and then the coolest and least massive of all stars are spectrotype M red stars, commonly referred to as red dwarfs. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectrotype M red dwarf stars, but became brown dwarfs after losing enough of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectrotype M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or 0.08 solar masses. The white dwarf Procyon B has about 0.6 times the mass of the Sun and a diameter of about 8,600 kilometres. A white dwarf is the stellar corpse of a Sun-like star. Having used up its nuclear fuel supply, fusing hydrogen into helium in the main sequence, it then expands into a red giant and begins fusing helium into carbon and oxygen. Stars like our Sun aren't massive enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelopes float off into space as spectacular objects called planetary nebulae. What's left behind is a superdense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool over the eons of time. Located about 11.6 light-years away, Procyon A has about 1.5 times the mass of the Sun and about twice its radius. It also has about 7 times the Sun's luminosity, making it unusually bright for a star of this type. And that suggests that it started to evolve off the main sequence after having fused nearly all of its core hydrogen into helium. It means the star is about to expand into a subgiant as it begins fusing core helium into carbon and oxygen and burning hydrogen in its outer shell. As it continues to expand, the star will eventually swell to somewhere between 80 and 150 times its current diameter. It'll then become a red giant. This will probably happen within the next 10 to 100 million years. The blink of an eye in astronomical terms. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of 15 astronomical units, about the distance of Uranus's orbit around the Sun. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Looking to the north-northwest now, and you'll see the constellation Leo the Lion, looking like a bunch of stars shaped like an upside-down question mark. Located just 36.7 light-years away in the constellation Bootes the Herdsman is Arcturus, a bloated, aging red giant, about 7.1 billion years old, and nearing the end of its life. Having used up all its core hydrogen, it's now fusing helium into carbon and oxygen. That's caused the star, which is only slightly more massive than the Sun, to expand outwards to around 25 times the Sun's diameter, and become about 170 times as luminous. It'll soon puff off its outer gaseous envelope as a planetary nebula, in the process revealing its white-hot stellar core. In Greek mythology, Arcturus was the guardian of the bear. Now this is a reference to being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. There's some indications that Arcturus could have a binary stellar companion, but the results remain inconclusive, at least for now. There's also speculation that it could have a large planet or substellar object orbiting it, something about 12 Jupiter masses in size, but again the research remains inconclusive. Looking to the east, and you'll see the three brightest stars in the constellation of Libra, the scales of justice, are visible about halfway, about 40 degrees above the horizon. These also represent the claws of Scorpius the Scorpion, which is chasing Orion across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii or Antares, the Scorpion's heart. Easily seen with the unaided eye, this red supergiant is some 550 light-years away, and it's one of the largest known stars in the universe. Antares has about 18 times the mass and an incredible 883 times the diameter of the Sun. And it's about 10,000 times more luminous than our Sun too. Okay, turning to the southeast now, and there you'll see the constellation Sagittarius, the Archer. It's important because it marks the direction to the centre of our galaxy, the Milky Way. And of course, located some 27,000 light-years away in that direction is the galaxy's central supermassive black hole, Sagittarius A star. To the ancient Babylonians, Sagittarius was the god Nergal, the centaur, a creature half man and half horse. By the time Greek mythology took over, Sagittarius was carrying a bow loaded with an arrow and pointing directly towards Antares, the heart of Scorpius the Scorpion. The centre of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. The brightest star in Sagittarius is Epsilon Sagittarii, or Cors Australis, the southern part of the bow. Epsilon Sagittarii is a binary system located 143 light-years away. The primary star is an evolved spectral type E blue giant at the end of its life on the main sequence. It has about 3.5 times the Sun's mass and about 7 times its radius, and is radiating around 363 times the Sun's luminosity. It's also a very strong X-ray source, and is spinning very rapidly, with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. Now, the second star in the system appears to be inside this debris disk. Astronomers think it's a spectral type G yellow dwarf star with about 95% the mass of the Sun. The second brightest star in Sagittarius is Sigma Sagittarii or Nunki. The name Nunki is Babylonian, however its meanings are unknown. It's thought to represent the ancient Babylonian sacred city of Urdu on the Euphrates River. Now, if correct, that would make Nunki the oldest known star name in current use. Nunki is a spectral type E blue star, located about 260 light-years away. It has about 8 times the Sun's mass, 4.5 times its radius, and about 3,300 times the Sun's luminosity. Alpha Sagittarii or Ruckbat, meaning the Archer's Knee, is a spectral type B blue star. Located some 182 light-years away, it has some 2.5 times the diameter of the Sun and about 40 times the Sun's luminosity. Astronomers think it's surrounded by a dense debris disk and a newborn companion star which is only now about to join the main sequence. The The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the Lagoon Nebula Messier 8, a spectacular pink emission nebula located 5,000 light-years away and measuring some 140 light-years by 60 light-years across. The central region of the Lagoon Nebula is also known as the Hourglass Nebula because of its distinctive shape caused by matter propelled by a massive star-forming region called Herschel 36, one of the few star-forming nebulae that it's possible to see with the unaided eye. The Lagoon Nebula was instrumental in the discovery of Bok globules, more than 17,000 of which have been found in the nebula. Astronomers think Bok globules contain embryonic protostars destined to eventually become new stellar generations. Also located in this region of space is the stunning Messier 17, better known to pretty well everyone as the Horsehead Nebula. It's located some 4,890 light-years away and is a dense region of ionized atomic hydrogen. Also known as the Omega or Swan Nebula, it spans some 15 light-years across and has about 800 times the mass of the Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry similar to the Orion Nebula, except that it's being viewed edge-on rather than face-on. The open star cluster NGC 6618 lies embedded in the nebulosity, and its gases cause the nebula to shine due to the intense radiation from its hot young stars. Open star clusters are loosely bound groups of stars, usually containing a few hundred to thousands. They're thought to have originally all been formed in the same molecular gas and dust cloud, but they're not as densely bound together as globular clusters. Open star clusters generally survive for a few 100 million years, with the most massive ones maybe surviving for a few billion. Now, by contrast, the more massive globular clusters exert such a strong gravitational attraction on their members they can survive for tens of billions of years or longer. The nebula is thought to contain up to 800 stars. More than 1,000 additional stars are also being formed in the surrounding molecular gas and dust clouds. It's also one of the youngest known clusters, with an age of just 1 million years. The cloud of interstellar material which formed the nebula is roughly 40 light-years in diameter, and it contains at least 30,000 solar masses. The Trifid Nebula Messier 20 is another large star-forming emission nebula containing many young hot stars. Located between 2,000 and 9,000 light-years away, the Trifid Nebula has a diameter of around 50 light-years. The outside of the Trifid is a bluish reflection nebula, while the inner region glows pink thanks to ionized hydrogen. There are also 2 dark bands dividing the Trifid Nebula into 3 regions or lobes. Hydrogen in the nebula is being ionized by a central triple star system which formed at the intersection of the 2 dark bands, creating its characteristic pink color. Another star-forming region in this part of the sky is NGC 6559, located some 5,000 light-years away and containing both red emission and blue reflection regions. Now, the grouping of these 3 nebulae, the Lagoon Nebula, the Trifid Nebula, and NGC 6559, is known as the Sagittarius Triplet. Another object worth looking out for is the Red Spider Nebula, NGC 6537. It's a planetary nebula about 8,000 light-years away. It has a prominent 2-lobed shape that could be due to a binary companion or simply magnetic fields, and it has a fascinating S-shaped symmetry, with the lobes opposite each other appearing similar. Again, this is believed to be due to the presence of a companion star to the central white dwarf. As for the central white dwarf, the remnant of the original star, it produces a powerful 10,000-degree hot, 3,000 km per second stellar wind, which is generating 100 billion kilometre high waves from supersonic shocks formed as the local gas is being compressed and heated in front of the rapidly expanding lobes. Atoms caught up in these shocks are radiating invisible light, giving the nebula its unique spider-like shape and also contributing to the nebula's expansion. The star at the centre of the Red Spider Nebula is surrounded by a dust shell, making its exact properties hard to determine. Its surface temperature is probably somewhere around 250,000 degrees, although a temperature of up to 500,000 degrees can't be ruled out, which would make it among the hottest white dwarf stars known. Now, looking directly south right now, you'll see the star Polaris Australis, or more accurately Sigma Octantis. It's the nearest star to the southern celestial pole and consequently the counterpart to the northern star Polaris. However, Sigma Octantis is far harder to see than Polaris because it's much fainter. Located some 270 light-years away, it's an orange giant reaching the end of its life. Now, turning to the southwest and just above the horizon, you'll see the star Canopus. It's the second brightest star in the night sky after Sirius. Canopus is located some 310 light-years away and is the brightest star in the constellation Carina the Keel. Canopus is a supergiant some 9 times the mass of the Sun and 71 times its diameter. The month of June also marks the first of 2 annual encounters with the Taurids meteor shower. The Taurids are generated as the Earth passes through the debris stream created by the comet 2P Encke, which itself could be part of a larger comet which broke apart about 20,000 to 30,000 years ago, most likely following numerous interactions with the powerful gravitational field of the planet Jupiter. As their name suggests, the Taurids' radiant, or apparent point of origin, is in the constellation Taurus the Bull. The Taurids meteor shower is made up of larger, more massive material. Think of pebbles instead of dust grains. Earth passes through this stream twice every year, once in June, then again in October, where it's called the Halloween fireballs. The Taurids releases material both by normal cometary activity and also occasionally by close encounters with the tidal gravitational force of the Earth and other planets. Now, all this combines to make the Taurid stream of material the largest in the inner solar system. And since the meteor stream is rather spread out in space, the Earth will take several weeks to pass through it, causing an extended period of meteor activity compared with the much smaller periods of activity for other meteor showers. Now, included in the Taurid stream is a denser flow of gravelly meteoroids called the Taurid swarm. It's thought to be a ribbon of rocks roughly 75 million kilometres wide by 150 kilometres across and held in orbit by Jupiter's gravity. Now, occasionally the Earth will pass through some of the larger meteoroids in the denser Taurid swarm, and that can make things rather interesting on Earth. In fact, one of the larger chunks of the Taurid swarm is now thought to have been the cause of the infamous Tunguska meteor event in the skies over Siberia on June 30, 1908. The Tunguska event is now believed to have been the airburst of a 100-metre wide meteor over the Tunguska region of Russia, causing mass devastation and flattening more than 2,000 square kilometres of forest into matchsticks. In fact, the blast was so bright it lit up the skies in London a third of the way around the planet. Tunguska remains the largest known Earth impact event in recorded history. It was considered a 1 in 1,000-year event, assuming a random distribution of events over time. But new studies suggest the event may have been caused by a Taurid swarm meteor. And with Earth passing through the swarm periodically, it changes the odds significantly. Now, if this study is correct, the swarm heightens the possibility of a cluster of large impacts on Earth over a relatively short period of time. Further complicating matters, the June Taurids are actually seen as 2 separate showers. The southern Taurids are the ones associated with the comet 2P Encke, while the northern Taurids originate from the asteroid 2004 TG10, an eccentric kilometre-wide asteroid classified as a near-Earth object and a potentially hazardous asteroid of the Apollo group. Jonathan Nally is the editor of Australian Sky and Telescope magazine. He joins us now for the rest of our tour of the June night skies.
G'day, Stuart. Well, yeah, it's June, so for us in the southern hemisphere down here where I observe from, we've got the galaxy, our Milky Way, stretching across the sky from the east to the west at this time of year in the sort of early evening when it's nice and dark down here because it's winter time. So yeah, Milky Way stretching all the way across the sky from the east to the west. We've got the Southern Cross down there in the south. It's about 2/3 of the way up from the horizon, from the southern horizon, and standing pretty much upright. It looks a bit like a kite, and it's pretty easy to see because most of its stars are nice and bright. Over in the west, just above the horizon, you've got the brightest star in the night sky, Sirius. But it's about to disappear. It'll give it another few weeks and it'll be below the western horizon after sunset, so it'll be gone for this season. Around to the left of Sirius, in the sort of southwestern part of the sky, we've got the second brightest star in the night sky. That's called Canopus. and it's in the constellation Carina. If you're in a dark location with clear skies and you can get a good view of the southern horizon, have a look to the south and see if you can spot the two Magellanic Cloud galaxies. Now, these galaxies are quite large, but they're very faint. They look like dull smudges or clouds. That's why they call them Magellanic Cloud, because Magellan spotted them and thought, oh, what are those clouds up there in the sky? And they didn't move, so obviously they're not clouds. They're actually galaxies, tens of thousands of light years away from us. So they are the nearest sizable galaxies to our own. So if you've got some good dark skies, as I say, you can look down to the south and see if you can spot these two galaxies. One's bigger and one smaller. You've got the large Magellanic Cloud and the small Magellanic Cloud. Up in the northern half of the sky seems a little bit bare this time of the year, but there's a couple of bright stars. There's a bright star called Arcturus, which can be seen about halfway up from the northern horizon. Much higher, almost overhead, in fact, there's another bright star called Spica. Now, Arcturus is a red giant star that's a couple of billion years older than our sun. It's the same mass as the sun, but it has ballooned up to be about 25 times bigger because it's older. When these sort of stars get old, they enlarge. So this one's 25 times bigger than our sun at the moment. Spica, the other star I mentioned, it's a binary star system, and the pair of stars in this system orbit each other so closely that it only takes 4 days to go around each other. And their mutual gravitational pull has stretched each of these stars from a round shape into an egg shape with the pointy bit pointing towards each other. So that's pretty amazing. I mean, two massive stars, can you imagine that, orbiting around each other, only taking 4 days? It's honestly, some of the things that are out there in space are pretty mind-blowing, and we live in a, fortunately, very sedate, quiet solar system where these sort of things don't happen. Otherwise, we might be in trouble. Now, as the night goes on, you'll see that things have changed as the Earth is turning. By midnight, as I say, Sirius is gone in the west. In the north, we've got the bright stars Vega and Altair have appeared. And down in the southeast, we've got a star called Achernar, which is a star that's at the end of a really long constellation with no other bright stars around it. So it sort of sticks out like a sore thumb. So it's pretty easy to spot. And the Milky Way, which was stretching from east to west across the sky, is now stretching basically from north to south. That's because the Earth has turned on its axis. So things that were below the horizon a few hours ago have now come up into view over the eastern horizon, and things that were visible in the western sky are disappearing from view as they go down below the western horizon. Now let's look at the planets. The innermost planet, Mercury, is pretty much out of view at the moment. You really won't have any chance of spotting it. Because Mercury orbits so close to the sun, it doesn't appear very far from the sun in the sky when we have a look at it. Start that again. Because Mercury orbits so close to the sun, it doesn't appear very far from the sun when we look for it in the sky. So at the moment, its orbit is taking it around to the other side of the sun from us, and so it's lost in the solar glare. It'll be back next month, though. Venus is very easy to see at the moment. If you go out and look to the west after sunset, you just won't miss it, unless you've got cloudy skies. But if you've got nice clear skies, you'll just see this big, bright, bold, star-looking thing. But that's the planet Venus, and you won't mistake it for any other stars around because it is much brighter than them. It's the biggest, brightest thing that's out there other than the moon.
The thing about planets, they don't twinkle like stars do in the night sky, do they?
They don't twinkle like stars when they're a reasonable elevation above the horizon. The common explanation for that is that stars are so far away that they are effectively a point. They're effectively a tiny point of light. And that light that's coming in through our atmosphere gets disrupted and disturbed and broken up by the air currents in our atmosphere. Whereas the planets, even though they appear to be tiny dots of light as well, they do actually have a discernible size, and that helps to sort of compensates for the twinkling effect. But if the planet is way down low, like just above the horizon, then they do seem to twinkle. They can seem to twinkle. There have been plenty of instances. I mean, I had a friend ring me up one night and said, there's this red light. I've been going out every night, and there's this red light out over the ocean from where I live, and it's winking and blinking, and I don't know what the Air Force is doing out there, or a UFO, or whatever it is. So I quickly checked my software, and I said, mate, that's Mars. And because it's so low down on the horizon, it's having to shine through more atmosphere sort of coming sideways towards us than it would if it was directly overhead where you're going through less atmosphere. So yeah, the planets can twinkle if they're low down, and it leads to all sorts of UFO reports and other things. And also, not so much a twinkling effect, but people have been startled, for instance, by Venus. We're just talking about Venus. You know, when you're driving along a road and you go along an avenue of trees on one side or either side that are carefully spaced apart, you can get a sort of a strobe effect if there's anything on the other side of it. Yeah, well, that that can really fool the eye and the mind. And I recall one report of a woman driving along, and there's this big bright light out to the side, and she was driving through an avenue of trees, and just the optical effects made it trick her into thinking this light was following her, whereas it wasn't. It was just this sort of optical illusion you get when you drive through an avenue of trees with a light out the side. And it's very easy to be fooled by things you're not expecting to see, and if you don't quite know what they are. That's why we do have a lot of so-called UFO reports. Now, Venus. Okay, we're talking about Venus, but up higher than Venus, if you go out and look for Venus, you can't miss it. Big, bright, white thing. If you look up above Venus, you'll see what looks like a medium brightness reddish star. This is what we were just talking about. It's not actually a star, it's the planet Mars. Okay, so you won't see it twinkling, most likely, but it's not very big and it's not super bright, sort of medium brightness. Now, keep an eye on both Venus and Mars over the next few weeks, and you'll see them get closer and closer and closer together. And by the end of the month, they'll be really close together as we see them from Earth. They're not close together actually in space, of course. It's just a line of sight effect. But if you do have good weather over the next few weeks, go out, just give them 5 minutes each evening if you can, and just look at Venus and look at Mars and just compare their positions night after night after night, and you'll see that they're slowly drawing together. And that's just these planets going around in their orbits and us going around in our orbit and getting a changing perspective, line of sight perspective from where we are. So you can actually really, not seeing it in real time as such, but if you call night after night real time, I guess you can say that night after night we're seeing in real time the dance of the planets around the sun. So that's really fun to do. You know, particularly take one of your kids outside and say, look, that's Venus, it's Mars, and let's go out like either a couple of nights from now or next week and see how they've changed. It really is quite nice to see that the things up in the sky are not static. Well, some things are not static, at least. The planets do move.
A nice after-dinner walk.
Yeah, when you're out walking the dog or whatever, just look up. Most people don't look up too much, you know. So just look up and have a look at the sky, and you see there's lots of good things to see. One of which will be Saturn. Now, Saturn can be seen rising over the eastern horizon about an hour before midnight, start of June. And take a look on the 10th of June, if you're having trouble spotting which one is Saturn, and you'll see that the moon is very close to it. So if you go out and see the moon, I mean, you can't miss the moon. The bright star, in inverted commas, near it is actually the planet Saturn. It has a slightly yellowish sort of tinge. And the last one, Jupiter. If you want to see Jupiter, well, you're going to have to be a bit of a real night owl or a very early riser, because coming up over the eastern horizon about an hour or so, hour and a half before dawn. Okay, so if you're up early or you have pulling an all-nighter, you might be able to go outside before you go to bed. Have a look for Jupiter. You can't miss Jupiter. Just like Venus, it too is big and bright. I think it's a bit brighter than Saturn at the moment. Saturn too is quite bright, but Jupiter and Venus typically are very, very bright, so you won't be able to miss it. My eyes see Jupiter as pretty much white-ish, but Saturn has a definite yellow tinge. Yeah. Mars is definitely a ruddy reddish orange. Venus is generally bright white, and so is Mercury. But it does depend on your eyes. It depends on whether you're looking through air pollution. It depends whether the planet's down low or up high, because certain wavelengths get absorbed by the atmosphere, particularly when they're down low. So that's actually a good test. You go outside with someone you know and say, okay, what colour do you see? And in fact, because our eyes, if it's nighttime and there are no lights around, everything's dark, our eyes are using the part of the retina that is good for picking up low light levels, but is not really good at colour. That's why things mostly seem black and white at night, because light is everything's pretty dim at night. Whereas during the daytime, when everything's nice and bright, we don't have any trouble seeing colour. And that reminds me actually of the famous scientist George Gamow, his famous thing about, he proved scientifically that the moon is better than the sun. Did you know this?
Tell me more.
He actually proved that the moon is better than the sun, because he said the moon shines at night time and it gives us illumination when everything is dark, which is really handy, you see. But the sun, well, it only shines during the daytime when it's light anyway.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. This is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.